See if this works. Okay. So my train is obviously here. Okay. 20 meters is here. 10 meters is there. Excuse me. We have an acceleration of 1.8 meters per second squared in that direction. Initial velocity of 0. So that's my givens, with my hidden being right there, obviously. My asked for is V final, or V. V is usually V final, just so you know. So we want to know V at 10 meters, I think. So I'll call that V10. And then my equation. So how do I figure out which equation to use? Very simply, look at what you have. V0, A, and X. So what equation has V0, V final, A, and X? Do you have an equation from your text notes? If you don't have this equation, shame on you. Okay? Clearly, this is a shame on most of you. Sean, do you have it?
I got V equals V is the initial velocity was final velocity over 2.
Can you use? Well, do you know the initial? Well, but like, what do you mean? If you isn't that for V bar?
Oh yeah.
Yeah. See, we need V this, so it comes out to be something like this: V squared is equal to V0 squared plus 2ax. That equation should be on your sheet. Go online tonight and print out the formula sheet. So you have it, and then make sure all your formulas on there. So we have this. So obviously, that's my equation. V squared equals V0 squared plus 2ax. Now I'm going to isolate, which is pretty easy. So I say V is the square root of 2ax. Right? Because what happened to V0? Yeah, V0 was 0, so I could just get rid of it. Right? And so then I get 2 times 1.8 meters per second squared times 10 meters. And then that gives me 36, and the square root of 36 is 6 meters per second. And we have our answer. Wait, so we'll find out. I'm assuming blue dot means recording. The second question is, what is the velocity at 20? Is this velocity less than 2 times as big, 2 times as big, or greater than 2 times as big? So, less than 2 times as big, it is 2 times as big. Oh, sorry, I should be doing this. I should do this. Less than 2x, 2x, or greater than 2x. Okay? Less than 2x, 2x, or greater than 2x. Okay, how many people think less than 2x? Raise your hand. Nobody. How many people think it'll be exactly twice as fast? Raise your hand. Okay, 2. How many people think it'll be more than twice as fast? Okay, most of the people chime in. All right, let's take a look. If we know V10 is equal to the square root of 2ax, yes, with x being 10, then does it make sense to you that V20 is equal to the square root of 2 times a times 2x? Does that make sense? Yes? Any questions on what I did there? Let's put a 2 in front of the 10, that's it. So do you see that that equals the square root of 2ax times the square root of 2? Did I lose anybody? Okay, in case you haven't noticed, I do that a lot. Like I say, are you with me? Do you understand? If you don't, please say so. Please say so. Okay? And then, after this, because of this, what do I know about this? I know that the square root of 2 is less than 2. So it's got to be less. You see it? So V20 is equal to V10 times the square root of 2, which is 1.414 blah, 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 times V10. Sorry, let me go ahead and do that. For the last part, the question is, what is V20? And it's the 1.4 times the 6, so you get something like 8.4 meters per second. Question? And remember, when you're going to be taking the quiz, it's going to be like one of these problems. So make sure that you practice them. All right.